Okay, so we are going to talk about how solving subtraction problems requires the opposite of subtraction. The inverse of subtraction is addition. So the teaching point here says to use the inverse operation to isolate the variable. And what I mean by isolating is making it alone, all by itself, on one side of the equal symbol. Okay? So this is your goal in algebra, x all by itself. If you look at example A, it looks very similar to the ones that we've been doing lately. So I'm going to say the opposite of subtraction is addition. I will use addition on both sides. This is my inverse operation. So far in yesterday and on Friday's classwork, we've been subtracting from both sides. I hope that your habit isn't just to do that, but I hope your habit is to look at the question and to do the inverse of it. Okay? All right. Now what I'm going to be showing you next is a simple rewriting of what you see up and down. I am now going to write this problem that you see left to right. Here I go. Here's my original question, x minus 5. I am going to add 5 to it. Over here, on the other side of the equal symbol, is 12 plus 5. By switching color pens, I intend to show you some of the rules of integers that we know. Whenever there's subtraction, we can change it to addition. So this is going to become x plus, what happens to that 5?
Negative 5.
It becomes its opposite, negative 5. Here's a rewriting of where I am so far. Are there questions about where I am? Okay, using my highlighter, I am going to show you this is a zero pair. By zero pair, what that means is a number plus its opposite will always equal
0.
Thank you, 0. So this is a 0, and I have the rest of the problem now. X plus 0 on one side of the equal sign, and over here 12 plus 7, 5 is 17. The property of 0 is that anytime you add 0 to a number, it doesn't change itself. So x doesn't change, it's simply x is 17. Are there questions about that so far? No? It makes sense? Okay, I'm going to pause here.